You're welcome to Dynamic Educational Hub channel. In this video, we are going to solve some physics past question in your JAMB, in your NECO, in your IGCSE. So without further ado, let's start. We have the first question here, which is, which of the following consists of entirely vector quantities? A. Tension, magnetic force, and mass. B. Displacement, impulse, and acceleration. C. Work, pressure, and moment. D. Velocity, magnetic flux, and reaction. So which one is vector quantity? Remember, vector quantity has magnitude and direction. So tension is a vector quantity. Magnetic force, it is a force, vector quantity. Mass, scalar quantity. Displacement, vector quantity. Impulse, vector quantity. Acceleration, vector quantity. If you look at this one, work is not vector quantity, it is scalar. If you look at this one, magnetic flux is not a vector quantity. So what's our answer? We have B. So the next question, which of the following is not a vector quantity? Wow, we have mass, weight, displacement, velocity. Vector, vector, vector. This is a force, vector. Now this one is a scalar, mass. Which of the following is not fundamental? Now look at what we have here. They are telling us which of the following is not a fundamental unit. Now we have 7 fundamental units. Now Kelvin, unit of temperature, which is fundamental. Steradian, I don't know it. Candela, unit of luminous intensity, which is fundamental unit, fundamental quantity. Now we have mole, amount of substance, unit of amount of substance. So which one is the answer? Steradian. So the next question, which of the following units is the SI unit of heat capacity? Now what is heat capacity? This is the amount you need to need láti increase temperature anything by 1 degree Celsius or 1 Kelvin. Òun náà pè ní heat capacity. The amount of heat that is required, that is needed to increase the temperature of substance, of body, of material by 1 Kelvin or 1 degree Celsius is known as heat capacity. Heat energy is mass multiplied by specific heat capacity. Isn't it? Mass multiplied by specific heat capacity multiplied by change in temperature. In the question, they are asking you heat capacity, not specific heat capacity. So they are asking MC here. Now, make your MC solid of formula. Your MC is going to be what? H divided by change in theta, which means Joule divided by Kelvin, and that will give you Joule per Kelvin. Be careful, Joule per Kelvin. So the next question, which of the following unit is derived? Unit, they are asking us derived units. Let's do Kelvin, fundamental unit for temperature. Temperature is a fundamental quantity. Coulombs, that is charges. Charges, coulomb. Charges is not fundamental. So coulombs is the answer, but let's look at the other. Ampere, current, unit of current, which is fundamental. Mole, amount of substance, unit of amount of substance, which is fundamental. So which one is the correct answer? We have our coulombs. Each of the following unit is equivalent to the unit of electric current. Listen attentively. So look at it, electric current. What is the unit of electric current? We have ampere, Abi. Now what they are asking us here is the derived unit of ampere. Ampere is a fundamental unit, but we can still derive it. So which means that we need to define the meaning of current. Anila to some definition, right? Now what is current? Current is what? Is the rate of flow of charges. Charges divided by what? By time. Let me use my calculus. We have dq over dt. Change of charges over change in time. Now, what is the unit of charges? We have coulombs. Unit of time, we have seconds. Now, use your mathematics. So you now have coulomb per seconds. You see, coulomb per seconds here. 7th question, we have which of the following gives a fundamental quantity? Wow, they are just testing our knowledge. Let's see how to solve this. Gives fundamental quantity. Now, mass times acceleration, that is force, isn't it? Force is not a fundamental quantity. Force divided by magnetic flux density times current. This one is talking. This one, you are not going to get anything with this one. Now let's look at C. Potential difference times work done. QD times work done. You're running. Impulse divided by force. I'm suspecting this one because impulse is what? Force times time. Let's see how to solve this. The correct answer is impulse over force. Let's see. Now, impulse is equal to what? Force times time. What will now be time? You divide both sides by what? Force. You now have impulse over force. What is time itself? Fundamental quantity. So D is the answer. The next question. A quantity specified by size alone is. When you are talking about the size, the magnitude alone for quantity, which one is the answer? So they are asking us scalar quantity. A, force. Force is a vector. B, momentum. Momentum is a vector. C, speed. Speed is a scalar. We now have D, acceleration. So which one is the answer? Speed. The next question, a component of vector x along the direction of vector y is 0 when the angle is 0. And obviously, if the angle is 0, it implies that what? Let's go. X is perpendicular to y? No, because the angle between them will be what? 45. X is an angle of 45 to y? No, they are still A and B the same thing. X and y are parallel to each other. X and y parallel to each other. What is the angle? 0. They don't have any angle between them. D. Down. So the answer is what? C. So the next question, the coefficient of friction between two perfectly smooth surface. Perfectly smooth surface. This one is coming from tribology, which is science of friction. Tribology, science of surface. Now let's look at how to solve this. Perfectly smooth surface. 100% smooth. It means that the grain size is extremely small. So which means that the friction will be what? 0. And you cannot have a perfectly smooth surface. So now A 1, B half, C 0, D infinity 0. The next question, JAMB loves something like this. I, force, and the unit is Newton. I, torque, Newton meter. I, current, ampere. IV, power, which is watt. Which of the following are the correct SI unit of the quantities indicated? Let's go. What is the unit of force? Newton. This one is correct. Torque is just like moment. It is force times perpendicular distance. This one is also force times distance. Times radius. Torque. Newton meter. Correct. What about current? The unit of current is ampere now. Correct. Power is what now? Correct. So 1, 2, 3, 4 is correct answer. We don't even need to read the option. Let's just go straight to what? To D. 1, 2, 3, 4. Correct answer. The unit of momentum is momentum. Let's divide momentum. Momentum is the product of mass and velocity. If I throw an empty bottle and I throw it at you and it hits you, you will not feel pain much. But let me put stone or sand inside that bottle and close it and throw it at you. Now, what you are feeling is known as momentum. Momentum is somehow similar to energy but different to energy. So, if I throw a ball at you, you can easily catch it. Let me go and carry a big stone. Or let's say there is something I used to carry a big stone and I throw it at you. That is momentum. Now, momentum mass times velocity, isn't it? So what will now be the unit? That should be, what is the unit of mass? Kilogram. But let's look at this option. We have Newton, we have Joule, we have Newton. So let's see how to solve it. It's very simple. Very simple. Now, the answer is Newton seconds. Let me show you why it's Newton seconds. Now, recall that momentum is equal to mass times velocity. Kilogram times unit of velocity is meter per second. So you now get kilogram meter per second. So you know that force itself, the unit is Newton, and the derived unit of Newton is kilogram meter per second square. Mass times acceleration. Mass kilogram, acceleration is meter per second square times acceleration, isn't it? Let's go. Come here. Momentum here will be what? Kilogram meter per second. Now let's do this. This one is similar to when you are doing, what is it called? This one is similar to when you are doing rationalization of sum. This is the principle. Multiply by seconds over seconds. Seconds can cancel seconds. So, but we just choose not to cancel seconds here. This thing, kilogram meter per second, is still the same thing as multiplying with seconds over seconds. Okay. Now, let's divide this one by this one. So we are going to have kilogram meter per second square. Just divide this one. S raised to power minus 1 divided by S. You are going to get S raised to power minus 2. Now this S that is here, multiply by it. So when you do all this, you still get this guy back. So we now have kilogram meter per second square times seconds, isn't it? Now look here. What is kilogram meter per second square? It is still Newton. Represent that. What are you going to have? We have Newton seconds. See, master this. This is JAMB question. The next one, the most precise in the following set of observation is. So we have some measurements here. The precise. So let's define precision. Precision is different from accuracy. But in this question, they're asking us precise. What is precision? Precision is the repetition of measurement. When you are taking a measurement, you're taking it the first time, taking the second time, taking the third time, and you are getting the same value. It means that you are precise. What about accuracy? Accuracy is when the measured value is close to the exact value, the closeness of measured value to the actual or exact value. That is known as accuracy. So now let's look at the measurement that seems as if it is repeating. 3.25, 3.26, 3.29. Let's look at the difference. The difference between this and this is 0.01. This and this is 0.03. Wow. Okay, let's look at this one. This one, it is far. B. Let's quickly move to C. Let's look at C. This one is, and this one, the difference is 0.01 difference and 0.01 difference. This one is the correct answer, C. Well, let's look at the last one. The difference, 0, between this and this, 0.02, between this and this, 0.02. So, Oshilofa. Now the answer will be C. This is the most precise. It's as if 6.3, 6.3, 6.3 is repeating. Now to this question, the resultant of two forces is 50 Newton if the forces are perpendicular to each other and one makes an angle of 30 degrees with the resultant. Find its magnitude. Let's come back here. The resultant of two forces is 50 Newton if the forces are perpendicular. Perpendicular means they are inclined at angle 90 degrees to each other. They are normal. So which means the angle between the two forces is 90 degrees. Okay. Now one out of them make 30 degrees with the resultant. So when you are asked to find its magnitude, the magnitude of that force, you don't know it. Now, but according to the question, we are given the resultant, isn't it? To solve this, you need a diagram. You can actually solve this within 1 minute. So let me show you. So let's visualize this question. So we have two forces. The angle between them is 90 degrees. They are perpendicular to each other. So let's fix the resultant force. To fix the resultant force, we are going to use parallelogram law of vector, the point of intersection between the two forces. So we have this, which is 50 Newton. So one out of these force makes an angle of 30 degrees with the what? With the horizontal. So we have what? 30 degrees. Yeah. So the other we makes an angle of what? 90 degrees here from the horizontal. 90 degree here. So we have to find the magnitude of this force. It's very simple. So which means we are going to resolve this resultant into vertical components for F2 and horizontal components for F1. Even if you put F2 here and you put F1 here, you can still solve it. So let's see how to solve it. So you have your F1 will be R cos theta. You resolve this one into horizontal component. F2 will be what? R sin theta. You resolve F2 into what? Vertical components. So we have what? F1 will be what? Your resultant R cos theta, because F1 is along the horizontal. F2 will be what? R sin theta along the vertical component. So now for F1, we are going to have R cos theta, and our theta is what? 30 degree. That will give you 50 cos 30 degree. 50 times 0.8660. Now you should know the value of cos 30 degree in short form. JAMB might not give you something like this. They can give you in short form. What is cos 30 degree? That's root 3 over 2. Now 50 multiplied by root 3 over 2. 50 times 0.8660, and you have 43.5 Newton. So instead of have 43.5 Newton, you can now have what? 25 root 3. Okay, what is the coefficient of friction between a wood of mass 1.6 kilogram and a horizontal surface, horizontal plane surface, if the limiting friction force is 8 Newton? Very simple. You are given the mass 1.6 kilogram. You don't need to do any conversion. You are given the limiting friction, static friction, your frictional force, which is 8 Newton, isn't it? We don't know the coefficient of friction. That is what we are looking for. Okay. So recall that your frictional force is equals to coefficient of friction multiplied by normal reaction, isn't it? The first law of solid friction. Now this normal reaction is mg. It's acting in opposite direction to the weight, and weight is mg. So that's why you have coefficient of friction mg. Okay. So we have to find coefficient of friction. So you divide both sides by what? Mg. Make coefficient of friction sort of formula. So you have a coefficient of friction will be what? Frictional force divided by R, or frictional force divided by mg, because R is mg. Substitute what you have here inside your formula. Your g, you should know that it is 10 meters per second square. So that will give you 8 over 1.6 times 10. 8 over 16. 1.6 times 10. Don't press calculator. Just shift this one here. It becomes 16. Don't press a calculator whenever you are multiplying by 10, 100, 1000. You don't need your calculator for that, Joe. So you have your 8 over 16. You still want to press calculator for this. So 8 divided by 8, 1. 16 divided by 8, you have 2. 1 over 2. You still want to press calculator for this, Abby. 1 over 2, you have 0.5. 2 cannot go in 1. You borrow 0. 0 here. You are going to return the 0. Okay? Returning it by point. Dot bar. Add 0 to 1. 10. 10 divided by 2. 1 divided by 2. Kò possible. 1 kéré sí 2. All of ya 0. Tó bá ti ya 0. Off 0 sí bíbí. Bam. 0 yẹn ó dá padà by point. Bam. So, ilé ti di 10. 10 divided by 2. 5. 0.5. So what will be our answer? 0.5. The next question, a 100 kilogram box is pushed along a road with a force of 500 Newton. If the box moves with a uniform velocity, the coefficient of friction between the box and the road is, wow. So you are given a box here, pushed along a road with a force of 500 Newton. This one is the moving force, pushing force. So if the box moves with a uniform velocity, wow, uniform velocity, the coefficient of friction between the box and the road is. Now to solve this, it's very simple. You are given the mass 100 kilogram. You are given the force that is used to move the object. Here, the moving force. Now this object is moving with a uniform velocity. So this one can also be your what? Your limiting frictional force, but don't let us call it limiting frictional force. Let's call it moving force, 500 Newton. So you call that this object is already moving. Abi? Yeah. So this one is moving with uniform velocity. So that means we are going to find Coefficient of kinetic friction is different from coefficient of static friction, but their difference is not much. So when you calculate the coefficient of static friction, the answer that you get, calculate the coefficient of kinetic friction, the answer that you get, it is just going to be slightly different. So static friction will be a little bit more than what? Kinetic friction. So let's find it. Now recall that your frictional force is coefficient of friction multiplied by reaction, isn't it? UMG, isn't it? Now, coefficient of static friction will now be moving force divided by reaction. Your moving force divided by mg. What is the moving force according to the question? 500, m 100, your g, then 500 over 1000. You still want to press calculator for this? I need to beat you. 0 cancel 0, 0 cancel 0. You're left 5 over 10. 5 in 5, 1. 5 in 10, 2. 500 in 500, 1. 500 in 1000, 2. 1 divided by 2, 0.5. So answer is 0.5. The next question, an object of mass 20 kilograms slide down an inclined plane at an angle of 30 degrees to the horizontal. The coefficient of static friction is, wow, I also love this. This one is actually simple. Given g is equals to 10 meters per second square. So according to the question, we are told that we have an inclined plane as shown. We have this box, slide down, push. So we have to calculate the coefficient of static friction. Wow. Now as it's sliding, kinetic friction, yeah. So we need to analyze the kinetic friction. So finding the kinetic friction, it will be close to what? Static friction, almost the same thing. So don't let us stress ourselves here. But to solve this, you use this. Coefficient of friction is tan theta. Tan theta, tan of the angle of the inclined plane. Don't stress yourself. So you have u is equals to tan 30 degrees. What is tan 30 degrees? 0.577. Now look at the option. Which one is close to it? 0.5. They are very simple. If you haven't subscribed to this channel, kindly subscribe to this channel. Watch my video, like, comment. Don't just watch. I beg you, like. It's not easy to do something that, as you are saying, it takes a lot of effort. Kindly like, share, subscribe. It's not easy to do video like this. Like, comment, subscribe, comment, share. Go easy. It's not easy. This is PowerPoint. Not easy. Like, comment, share this video. Make sure you also watch some other places. You can't be learning and not giving back. It's not good. So the last question, which of the following affects frictional force? A, the relative velocity of the surfaces in contact. B, the color. C, the area of contact of the given surface. D, the nature of the surface in contact. Wow. According to the law of solid friction, so frictional force does not depend on the area of contact of given surface. It doesn't depend on color. It doesn't depend on the relative velocity of the surface in contact. So it only depends on what nature of the surface in contact, either smooth, rough, wet, dry, lubricated, non-lubricated. That is what determines the frictional force between surface in contact. So D is the answer. Thanks for learning. Check out my various playlists and subscribe. Bye for now.